Okay. So Nick mentioned Web 2.0, and it reminded me of the fact that I think when you look at Azure, very compelling in terms of the impact that it can have in terms of transforming how we think about composite applications and services and whatnot, and particularly with a focus on the enterprise, right? So when I think about Azure Fabric Service Bus, I think it's one of the least understood technologies, yet one of the most powerful, in my opinion.
Yes.
And one of the things that I think has contributed to that lack of understanding per se is some of the marketing messages around App Fabric, and I know that we're working right now to kind of join those, and that message is landing, and we've been working hard in the field and within the community to really tell a single App Fabric message.
Right.
And I think it's key because I think that what Web 2.0 did for the internet, I think that Azure and App Fabric combined can do for connected applications. So I'm curious kind of where we are today in terms of accomplishing that fidelity. Obviously it's not going to happen overnight, but when I think about the capabilities that I have within eServer App Fabric brand and some of the things that are landing in Azure App Fabric, I was curious if you could kind of talk about how those are lining up.
Yeah, I mean part of the challenge honestly is that if you're coming from a hardcore large-scale enterprise, you've worked with other message buses and such. And so you're kind of used to that paradigm of thinking and leveraging those feature sets. Whereas this is kind of the first time where you could just grab it without having to spend $1 million on a deployment, and it's just available to you on a subscription. So part of it is just they don't really know it's like this massively powerful machine, and they don't really know what to do with it, but they know it's really powerful. So some of it's education about what you can do once you get it, and I think some of the work that you guys have been doing and several others have really been helping with that. I think getting some clarity just in terms of what problems we really want to focus on is something that we Microsoft need to really work on, because it kind of was this massive solution maybe in search of a problem at first, and now I think we've evolved that discussion down to there are certain problem spaces where these are really great places to drop it.
Yeah, and I think it's just it's cool enough to think of this internet scale pub sub channel, right? That's cool, but I think that what really elevates to the next level is we've gotten drunk over the last decade on request response, right? We've been doing request response forever. This notion that I can send a message from a asset in the cloud on premise without having to punch outbound holes in my firewall is phenomenal. Right?
Yeah,
and that's what I mean about that potential transformative technology.
Yeah, you're spot on, and I think one of the key scenarios I think going forward for any type of cloud development is going to be this hybrid scenario. Right? I give a lot of talks, and I get asked all the time, are you trying to get us to shut down our data centers? Is this an all or nothing? We don't want to do rip and replace, and that's not the point. I don't see anybody decommissioning a data center in the near future. I mean, near future being years and years, right? But if you're going to enable that hybrid scenario, communications is, okay, question one. If I'm not going to have stuff sitting next to each other on the same switch, how are they going to talk, right? So part of it is coming up with these patterns around, okay, well, there's certain apps that it makes just more sense. It's so much easier to leave the data where it is, move compute. Or it's easier to move a certain workflow or a certain stream out of the data center and run it. And so part of it is just coming up with all those patterns, right? Of, if you have this type of problem, here's an approach. And the approach involves moving compute here and leveraging the fabric to do this, and look, it's way easier than what you thought.
Sure.
Right? And you still get the
that makes sense, absolutely. Right? And I think dream state would be, to arrive at a day where we have a single cockpit, right? And we're truly operating with location transparency.
Exactly.
On the cloud premise, it really doesn't matter. So very interested to see what's coming out.
Yeah, and there are several factors. I mean, some of it's legal, right? There's just compliance issues or legal restrictions that's going to drive the hybrid. I think some of it is, frankly, it's emotional. It's my stuff. I'm not quite ready to not own my stuff.
That's absolutely true.
But I had somebody tell me the other day, the funny thing is, everybody forgets, but in 1997, how many people were putting their credit cards online? It was a tiny percentage. It really was. And Jeff Bezos actually has this great story about the day that Amazon launched. that their site went up, DNS entries are there, they tested the site, and they had this little bell that would go off when an order came in, and the bell didn't go off, right? And they're like, okay. It was like
the server, are you sure
right,
we're up?
It was like exactly. It was like 30 minutes, and then the bell rang,
Yeah.
right? And that was like the first credit card processing that they did, and then it was another hour before the next one, but that was only 50 minutes and 45. And he said it got to where the bell was just constantly going, and so they had to turn it off.
I think that's so true, and as David, I know from the test, and when we talk, there's not many customers we talk to that don't have the chemistry for cloud, right?
Right.
Our job is to help them find the psychology,
exactly,
and that's stuff.
And I mentioned this in our talk earlier, but I think a lot of it is there's this misunderstanding about, well, what about my operations guys? We have this tremendous talent pool. Where do they fit into all this? And Azure and the cloud is about abstracting out the hard parts about the mundane, giving these scalable and secure platforms that you can build on top of. But it doesn't replace that requirement for operational excellence. I actually think it makes it more interesting, right? I mean, you can. It's hard to measure the ROI of a great operations person. They're great, and you know that they're an incredibly valuable asset, but it's hard to put a number on that, right? And one of the things I like about Azure is it kind of eliminates this concept of TCO, because if you're metering everything and you're measuring everything, TCO is a logical construct for something hard to measure. Okay, well, if you meter everything and you measure everything, it's not hard to measure, right? You can actually put a number on it and say, because of our operational excellence, we were able to shave this much money off per month, right? And unless you're doing trivial apps, I mean, those numbers can add up extremely fast.
But it is a different world. So
it absolutely
moving
is.
from the old way, I have to figure out TCO, I have to do long-range planning, I have to budget it all, get approval too. And the cloud is more like watching, looking at your electric bill every month, just seeing how's it trending, do I like what's going on, do I understand why it is what the size it is.
Oh yeah, it absolutely is. I think it makes it more immediate. I really do. I think I was talking to a dev manager for a company, and what he really liked about it was it made it easier for him to request QA resources and performance resources. And it's one of these great ironies, right? And if you've been around dev for a long time, you understand the faster something is, generally the more efficient it is, and arguably the easier it is to maintain, right? It's a fascinating bit of connectivity, but in the cloud, the same thing is true, right? The faster it goes, typically the cheaper it is to run. And so what they're finding is that they can go to their management and say, hey, I need somebody to really do a full profile check and really let's walk the code, and let's find the issues, let's find where we're slow and where we're blocking. And then the next month they get their bill and it's lower, right? And they're like, oh, hey, we did this one investment and that pays for the life of the app. If you do no other check-ins, again, that's money in the bank for as long as that app is running. And that's actually a relatively easy argument to have.
And decision support is huge. And to your point, you start metering things. I think that's where technology like Stream Insight comes in.
Exactly.
Very, very powerful, right?
Yeah, and I think as we start getting into partners who are abstracting out, providing solutions to other, creating these multi-tiered ecosystems, that's going to be part of that discussion of, how much do we meter and how much do we expose, and it's really, I think, leading some interesting conversations. I'll repeat the question because our sound quality is not that great. So, question is, HPC Server 2008 R2 has Azure support. What did we have to do in Azure to get it to work, and what did they have to do to get it to work? And then what scenarios did it support? So, our original plan, to be honest with you, was exactly what you described. Was we would only support basically these SOA type scenarios because we saw that was where most of the future investment in apps were going to be anyway. But then we changed our mind, and we decided that we're going to support both the SOA, which is basically a web service wrapper type of scenario, and direct calls, which would be more of like the batch mode or parametric sweep scenarios where you're communicating directly with, say, the equivalent of an HPC agent. So it's not so much that there's a generic worker role that is HPC aware. It was actually more about putting the brains in the HPC head node so that it understood what an Azure resource was. And it actually enabled us to support a lot more scenarios than what we originally planned to do. And what we were finding when we were doing a lot of these parallel computing solutions was that the actual scheduling of a job and executing of a job actually isn't all that hard. I mean, Azure has a queue that you can leverage. It has a table. You've got these worker nodes, and actually you could throw something together over a couple days and kind of hobble it together. But you don't have any reporting. You don't have any dashboard. You don't have any retries, state, all the stuff that makes non-trivial apps, really work for the enterprise or work for the organization, right? And those were all problems that the HPC server team had already solved. So really, what's arguably the hardest thing for customers to build on their own, they'd already figured out, but they were just kind of missing this last mile of how do we talk to Azure. And so it wasn't so much we had to change Azure, so much we just had to make sure that our team members on the HPC team really understood what they had available to them. And so to some degree it was education. Some of it was talking to customers and coming up with patterns that made sense that people would really want. And then we ended up announcing it at I think it was called Grid on Wall Street in New York at the end of September. So the feedback has been extremely positive. We don't support all scenarios. There were some scenarios we just said, right now in the cloud, they're not great. It's not a good experience. MPI-based jobs. And that's actually true for most of the generic cloud vendors. It's not a great experience. If you go, there are some vendors, like SGI, to name one.
One major exception.
I would say it's adequate, not great. There are some vendors who actually are really, really good at it, and we work directly with them. And they provide, Windows-based, Linux-based. It's great, but part of that reason is that particular scenario has a dependency on deterministic layouts. If you really want to squeeze the maximum performance out, and that's why I say it's one thing to say you can do it adequately and that you can run it and the communications will work. But the latencies are so high, a lot of times it overwhelms the differential, and it makes it really, really slow because of the way the physics are actually factored, versus being able to provide a really great experience. And that's really what we want to focus on, is great experiences. So we are going to be adding more HPC features to Azure, specifically to enable more scenarios. Will they be as fast as an on-premise dedicated, highly tuned rack? I don't see that happening for quite a while, to be honest with you. But it would allow some of them to run, and it might be a way to do verification of the model, or if your alternative is waiting 8 weeks to get on a grid versus running it, at 30% slower. Well, I mean, even 30% slower, it's not 6 or 8 weeks slower. So you still end up a net gain. Does that make sense?
Yeah. So one of the things that sort of shocked everybody, because what you've described is sort of the status quo of what everyone in the scientific realm has assumed in the cloud, that data parallel apps that are low, where the compute to communication ratio is high, that they run well in the cloud or can run reasonably well, and that traditional MPI or tightly coupled apps won't. Amazon sort of surprised the world this summer with their CCI nodes, and not necessarily just the compute nodes, because that's just a different physical instance, but the fact that you get 10 gig non-blocking Ethernet between them, and particularly in our case, the fact that they ran LinPack on it and scored roughly 146th in the top 500. Sort of opened a lot of people's eyes to the fact that maybe we can run our stuff. Sure. Maybe we can do CFD or things like that. Are there plans, or are there plans that you can discuss to offer similar style compute?
Like I said, it's something we're looking at. A lot of it honestly has to do with what the actual market demand